as Greg said, I'm going to talk about Flask. So I've been watching a lot of conference talks, especially on Flask. And for me personally, I really like the talks where you go and the person will do more of a live demo and actually kind of walk you through, like, here's how you code, here's what it looks like, kind of like step by step, instead of just, you know, throwing it on the screen and it's all theoretical. So I'm going to try that. I think that'll be better, but I'm a little unsure on timing, so we might not get through everything, but I will put these up on GitHub, like all the code's already up on GitHub, and I'll also have some references to more stuff, so you'll have access to everything, and we'll see how far we can get. And Greg, what do we have till 8:30?
Around 8:30, yeah.
Okay. Okay, so just a quick background for myself. I primarily work in infrastructure. I'm not a developer. Developer is more of a side gig for me. So I've been trying to get more into automation. So for the past 3 years, I've been focusing on kind of getting back into what I call scripting, using Python. And that's been an interesting experience. And in my opinion, if you look at the IT space, I think that the days of not knowing how to program, in my opinion, are coming to an end. I think everybody's going to have to know how to program to some degree. Doesn't mean that you write C++ and Java code, but it does mean that at least you need to be familiar with tools like Ansible and basic automation. You know, Python's pretty easy, PowerShell, Bash, but you need to use some kind of tools to basically glue stuff together, right? Because if you look at the public cloud, if you look at all the new technologies, everything is more and more API-based, and APIs are not designed for human consumption. They're designed for programs. And there's lots of great tools like Postman and other things that make it pretty easy to use, but that's for me, that's what's kind of driving me down this path. And when I started this 3 years ago, I kind of had a hard time getting started, because when you get into something like a web framework, there's so many components, and I'm going to go over this in a minute, but there's so many things you have to understand. You have to understand the front end, the back end, databases, cookies, security, session management, JavaScript libraries. There's all these different things. And like trying to piece all that together at first can be pretty overwhelming. So this first one I really liked, the Udacity Nano degree. This is something that the company I work for promoted, which was kind of a break for me. And that kind of gives you a great intro. Miguel Grinberg, if you get into Flask at all, he is the man. So he has all the best classes. If you look at the PyCon tutorials, which is the most popular Python conference, they're all done by him. He's got a lot of good stuff. Matt McKay has fullstackpython.com. Pretty much any question you could think of, he's got the answer on that site. And then finally, I really like Michael Kennedy's Talk Python to Me podcast. So if any of this stuff is interesting to you, or you think you'd like to learn more, these are great resources to check out. And I also have some roadmaps at the end. Like I said, and that'll be on GitHub, so you can check it out at your leisure. Okay, so this is, for me, when I started this, again, I was trying to piece all this stuff together. So I thought it would be worth some time kind of looking at all the various pieces. And this might also be useful, too, in terms of thinking about future talks and things to look at. So basically, when I talk about the full stack, there's two parts. There's the front end and the back end. So the front end is basically the browser. So all the components in the browser. So HTML, CSS, JavaScript, your engine, your dev tools that are built into your browser. If you never played around with dev tools, all the browsers have them. They're really fantastic tools. The front end is dominated by JavaScript, right? Because that's what's built into the browser. All the browsers have a JavaScript engine. For people who prefer working with static types, you have TypeScript. So TypeScript tends to lend itself more towards bigger projects. So people who write, tens of thousands or millions of lines of code, seem to prefer using types. So that's an option. And then kind of the new kid on the block, I don't know if it was up on that Trello board, is WebAssembly or WASM. And that's kind of cool. I mean, I'm not going to talk about it here, other than to mention is the idea with WASM is it's basically assembly for the browser. So if you write in something like C or C++, you can actually compile into WebAssembly, And then the idea is, maybe that becomes like a universal language for the browser. So that's kind of an emerging area. It'll be interesting to watch. But unless that changes things, for now the front end is basically all JavaScript. And then you have the libraries. So we're going to have a talk on Angular. That'll be cool. React, Bootstrap. There are all these frameworks that basically give you a nice modern looking application. The back end is kind of what it sounds. That's basically everything on the server side. So I'm gonna talk specifically about web frameworks, but essentially on the back end, you typically hit a web server. So I'm sure everybody's heard of Apache and Nginx, or IIS on the Windows side. Those three basically dominate in that order. For Python specifically, you have WSGI, and we'll talk more about that in a little bit, but that's basically a Python application server, and then those are the most popular ones. And then basically the framework is how do you integrate with the WSGI server and the web server? So how do you basically, if I build an application in Python, how does all that fit together so when you open up your browser, you get to see an application? And that's what we're going to dive into. And then finally, for persistence, right? So when I create a user, when I create posts or data or something like that, I'm going to put it in a database. So these are all the various pieces, and we're just going to focus on this one. So there are going to be some missing details. The biggest one is I can't really go into databases because, we only have an hour and a half, and it's just, it's too much. So, but like I said, there are some resources at the end, so if you want to dive more into any of these areas, I have pointers. Okay, so just kind of quickly to provide a visual of how it typically works. If I write a Python web application, it's possible that I can run a WSGI server like gUnicorn directly, and you just connect directly to it. But that's typically not the way I want to do it. Typically, the way I want to do it is I run a dedicated web server, and the reason I run a web server is there are some things that are just better suited for a dedicated application. So especially something like encryption, right? Encryption takes a lot of processing power, it's hard, it's complicated, there's constantly flaws. So it's better to use something that you basically have a whole company or team of people that are devoted to that. Caching is similar, and then also basically just scale, right? So if I look at something like Nginx, it's designed to handle like 1 million connections, right? So why would I try and reinvent that wheel? So typically I'm going to leverage one of those web servers, and then basically within the web server I'm going to plug in my application server or web application server. So I was kind of curious. I looked around, so it seems like different languages have different ways of doing it. Like if you look at Java versus Python versus Node, they're all slightly different, but the idea is similar. You have some kind of an application server, and basically, like if I look at my Apache or Nginx config, I basically say, okay, for these URL paths, I basically am going to delegate those to the application server, right? So this guy basically plugs in, and then using that application server, using the framework, basically that's how I plug my application in. And basically the user gets to see the application. So this is a little bit of a simplification. When somebody goes to the application, it's actually going to kind of backtrack, but just for simplicity, that's the general idea. Okay, so when I look at a web framework, I wanted to talk a little bit about what does it give us? What does it offer? So the biggest thing is, even when I'm writing an application that I plug into an application server, I still have to be able to deal with HTTP, right? So HTTP is basically, you probably know this, but just for the sake of saying it, that's how the front and back end communicate, is using HTTP. So I have seen a handful of people that'll say, why do I have to use all this? How hard could it be to just write a simple socket server that responds to the request, right? So if you've never actually looked at, and this is actually not current because the current standard is HTTP 2, but if we go back, this is still probably the most popular, is HTTP 1.1. And just to give you an idea, like how complicated it is, there are dozens of standards, right? And if I basically look at any one of these standards, a lot of them are basically close to 100 pages of specification details, right? So if you wanted to write your own system that and you don't want to use a framework, you want to do everything on your own, you're probably dealing with, I don't know, close to 1,000 pages of specifications, and you got to do all that in a secure, robust, efficient, performant way, right? So what do you think, a couple hours?
Yeah.
Right? So I mean, this is the advantage of a framework, is it might not seem like web is that complicated, but it is. There's a lot there. So there are general areas that a web framework provides you, and different frameworks handle it differently. Some frameworks include all these, some you have to get options to do it, but we'll hit most of these areas except for ORMs. So routing is basically when somebody when somebody types a URL in the browser, right? How do I connect that to an actual function or a procedure in the code? So that's routing. Templates are basically my dynamic page creation. So when I actually the whole point of having an application act as a web server is it's dynamic. Because if I have static pages, you don't need an application, right? So templates make it easy to create those dynamic pages. Or if I'm doing an API, they make it easy to create the JSON or XML. Forms are basically how I deal with user input. So there's a whole bunch of stuff, especially in terms of security and validation, that they can help. ORMs are basically for the database, so any kind of persistence. Unfortunately, this is something that I had to exclude just because of time. But the idea with an ORM is when I want to store stuff, I believe relational databases are still the most popular. However, if I look at using a relational database, which basically means I'm using SQL, there's kind of a mismatch because SQL is declarative and kind of has a different style versus traditional programming languages. So it's nice if I can have a bridge. So like, for example, if I'm using Python, I create objects. So I basically create an object that represents my data, and then what the ORM does, the ORM says, here's how I go from this Python object to the equivalent SQL code in a secure way. So that's what ORMs give me. The other nice thing about an ORM is, if I'm talking about open source databases, so I'm talking about SQLite, MySQL, MariaDB, or Postgres, if I use an ORM, I can almost freely change the backend. So if this provider uses MySQL or MySQL and this provider uses Postgres, if I'm using an ORM, I don't care. It's really easy for me to change out the backend. And then if I want to go into one of the newer kinds of databases, like NoSQL, using something like Mongo, then I have an ODM, which is the same idea, except it's JSON instead of using SQL. Security, so security we're going to spend some time on. Security is really hard. There's all kinds of issues, and basically a good framework kind of helps protect us against some of the standard attacks. And then finally, sessions. So the simplest way to think of a session is, how do I know if somebody's authenticated to my website or not? Or what's in the shopping cart, things like that. Okay, so one thing I wanted to do too, before we get too far in, is just kind of give a brief lay of the land. So in terms of the most, so this is somewhat subjective, although I did do some research in terms of looking at GitHub and community and stuff like that. But in my opinion, these are probably the most popular Python frameworks. So by far, the most popular one is Django. So Django is kind of a batteries included, everything's there. It's pretty slick, and that's very popular, especially for big projects. So like one famous user is Instagram. There's lots of companies that use it. They have their whole own conference. They have all kinds of user groups. So it's a very strong community. Not too far behind Django is Flask, so we're going to talk about Flask tonight. Interestingly, Flask and Django are almost opposites. So Django is basically you get everything. Like everything's been thought out, everything's there, everything's done. But it's also a lot because it's everything. Flask is more like do it yourself or build it piece by piece, almost more like a Lego set. So Flask, I kind of like it as an IT person because you kind of see how all the pieces fit together, which can be kind of nice if you want to understand security of the infrastructure side. You have Pyramid, which is kind of a middle ground. So Pyramid can go from small to big, but it has a lot of flexibility. The complaint I've heard about Pyramid is you have to make a lot of decisions. So maybe you would want to start with that one, but that's another option. Tornado is like a completely different one. So this I think this is from Friend Finder, and Facebook acquired them, and then they released this as open source. And this is basically a complete application server. You don't even need to use WSGI. So this guy does everything. And there are some older Python frameworks, Tornado, another one is Twisted, and these are basically the older async frameworks. And the idea with async is this, has anybody heard of this C10K? So this is an older paper. It's about 10,000 concurrent connections. So if I go back like, it might only be 20 years now, there's different models of concurrency. So I have processes, threads, and async. Async is in like greenlets or basically like within the same thread. And processes are kind of like, that was like the first way we did concurrency. The problem with processes is they're very heavyweight. So like if you're using processes, at most you're gonna have tens, and that's about as far as you're gonna go, right? So you're not, if you wanna serve like thousands of people, you're not doing it with processes. It's not gonna work very well. The next one is multi-threading, where basically each process has a bunch of threads. So that's better. With multi-threading, now I can go from 10 to hundreds. Maybe you could even get up to like, I forget what the limit in Linux is, but I think it's somewhere close to 1,000. So with threads, you're talking, maybe hundreds, but that's it. The other problem is, I don't want to be concurrency talk, but threads, because they share the address space, you have to be really careful that you don't step on things. So it's really hard to write good multi-threaded code. And you still kind of hit the wall. So when people were looking at, okay, thousands of connections is good enough, I want 10,000. Or even if, does anybody know, just to give you an idea of how far we come, does anybody know like how much a one-use server can deal with in terms of concurrent connections? Anyone want to take a guess?
Depends on the physicals. Pardon me?
I
was going to say it depends on the physicals of the machine.
Well, so like a modern high-end machine, one-use server. So from I think it was from 2 or 3 years ago, it was up to 10 to 12 million. So using Java on Linux. So I mean, if you look at async, async is basically we just have one thread, but we slice up the time. And this is basically how Nginx works too. So this is kind of like if you look at Apache versus Nginx, the way that Nginx gives hundreds of times the scalability of Apache in terms of concurrency is because it uses this async framework. So that was the idea with Tornado and some of these older async frameworks was bring this to Python. And then basically with Python 3.5 and later, which has been out for a while at this point, now you have Sanic is one of these new async frameworks. So if I want like a web server that can deal with tens or hundreds of thousands of connections, I basically want to use this async code. And this is also like if you look at JavaScript and Node, it's the same model. They all use the same async model because it's highly scalable.
How many people are writing applications that need 10,000 more connections? I've got 140 users in my server.
Then you don't need it.
It might go to 150.
Well, I mean, and you know what? If you look at the most popular web server, it's still Apache. Because you're right, because a lot of people don't need that. But there is a sizable fraction of people that do need the massive concurrency. And even to your point, Jim, if you look at these web frameworks, look at what the most popular two are. They're still, by far, by at least an order of magnitude, it's still Django and Flask, right? So you're right, that's still most people. But, if you do need it, there are options. And async is pretty cool because unlike multi-threaded, if you look at some of the modern async techniques, they're not that bad.
Yeah, I'm using Node.js or something.
Yeah, it's the same. It's exactly the same. So because multi-threaded will really like twist your brain, but the async stuff is not too bad.
So I just wanted to throw in there. I guess it kind of depends on the size of your infrastructure that you're working with too. So like at my current job, we have about 6,000 systems, and each one of those might have a little piece of information that's served by like an API. So let's say you have like configuration management that's calling one of your APIs, it might make 5 or 10 API calls for a single system. You know, you start scaling that out to thousands, you get, you know, whatever times thousands times how
Yes,
many
it
API calls
goes up
make.
quick.
Yeah. So scalability is definitely something to look into in choosing one of these.
But you're right, you know, it definitely depends on the use case.
If you're starting fresh, is there a reason not to go with Sonic or Sonic instead of?
Sanic is good, but it's still newer. It's not as polished as,
Sure.
as like Django or Flask, because, you know, they've just been around, you know, Django's been around since 2000, really before 2005. So, I mean, they have everything. But probably the biggest reason is if you need to use async style programming, like for example, WebSockets or WebRTC, if you want to do that, then I would definitely look at Sanic. Because if you're talking about WebSockets, you know, that's something that needs like a great deal of concurrency. It's really painful if you try and graft it onto the older frameworks that aren't async based.
That's why I'm using Node.js for a website.
Yeah, there you go. So, but again, it's all about the use case. Okay, so I just wanted to do a quick hello world, you know, just to kind of do a level set. So if I look at this guy, how many people have dealt with Python? Just to give you an idea, anyone or? Oh, pretty good. Okay, so half. Okay, so the top is basically I'm importing Flask, so let's usually have some variant of that in the language, and then basically in this case it's an object. So I'm instantiating Flask as an object. So my app, that app variable represents a Flask object. And then we're going to talk about routing in a minute, but basically this add is what's called a decorator. So it's kind of like a wrapper. So I'm taking this hello world function and I'm wrapping it in that app.route. And basically what that's doing is that's saying if the user goes to the root directory to / in the browser, it's going to map it to that function. And that function's output is what's going to be displayed on the user's browser. And then this piece at the bottom, this is kind of weird if you've never done Python, but basically this is saying that if we run it directly, we're going to start the server. If we use it as a library where we're importing it like at the top, then we won't. And then basically I run this just like any Python script, just Python in the name, and then basically it starts up. So Flask has a built-in kind of debug type server. You definitely do not want to use it for production, but for developing on your laptop and testing it out, it works great. And so you fire this up. Oh, I thought I had a visual, but I don't. And then yeah, and then you can go to it in the browser, and that's hello world. So that's you know, that's the basics, and then. So just kind of reiterating what I just talked about is we basically Flask builds up this table. So for each URL path, there's a view function. So that decorator on top is basically mapping the URL path to a specific view function. So again, so when I point this address. And then one other thing too, by default, Flask listens on port 5000 on localhost. I mean, you can change it to anything, but this is the default. So if I just go to localhost 5000, that implies like the root directory or /. So basically this goes into the Flask Whiskey server, this request. Then Flask basically maps it to the view function, and the view function basically returns the output, and that's what's displayed in the browser. So that's how basic routing works in any web application framework. I mean the mechanics are going to be different, but that's the general idea. Okay, and then so just to kind of discuss what I want to use, I'm using Python 3.6. I've actually been meaning to switch to 3.7, but I haven't got around to it yet. I like virtual environments. I'll talk about that in a second. And then I use Git as my source control system, and I put everything up on GitHub. And the way I did this, and I got this idea from taking Miguel's course, is so here's my repo up on GitHub, and then basically if I go into my commit history, what I did is I basically, I built the app in stages. So you can kind of go through each stage, and then basically what I did with each stage is I actually tagged it. So you can actually do like a git, and I'll do this as I go. You can do a git checkout and a tag, and then you can basically go through each of the stages, and you can see like what's changed. Because I really like this when he did this, so I guess I hope you found it useful. But then like when I go into like, for example, adding routes, you can go in and you can see exactly what changed. So as you go through each stage, you can see, okay, this is what we added, and you can actually see in the code everything that changed. So if you're interested in this, hopefully that makes it easy to follow. All right. So I'm not going to walk through installing Python. We'll assume you have that. So I don't know if we'll actually have enough time to follow along, but that's my repo. So anybody, if you have Git or it's easy to install it, works on pretty much anything, you can clone the repo and then go through. Virtual environment. So in Python, a virtual environment is essentially, you have your main Python install, and then you can create a virtual environment that's basically isolated from a package point of view. So like, for example, if I'm running my main Python instance on my system, I have all my system packages. And then if I install stuff, that's okay, but like sometimes, like for example, if I want a newer version, especially like on Linux, I have to be careful I don't want to break something, right? So the idea with the virtual environment is I create this virtual environment and then I can put whatever I want in it, and it just impacts the application. I don't have to worry about messing up anybody else or messing up anything on the system. The other really nice thing is, like for example, one time I was writing an app that interfaced with Twitter. And when I looked at the app I was using, the library I was using to interface with Twitter, I needed something from the latest version. I actually had to clone it right from GitHub and then install it. And I was just thinking, like, you know, that was not good that I did it, because now I manually installed it. I can't, there's no uninstall. Right, so that's why you have a virtual environment. So if you're experimenting with kind of cutting edge stuff, you don't have to worry about breaking your system. And then finally, for more and more, reproducibility is important. So if I put everything in a virtual environment, in that virtual environment I can say, here are the exact libraries I use for this application and the exact versions. So then it's easy for anybody else to do exactly the same thing I did. No matter if you do it on Mac, Linux, Windows, it doesn't matter. So I highly recommend it for that. And then activate it. So when you set it up, you have to basically, when you set up your virtual environment, like I said, it starts out empty. There's no libraries installed. And so you have to install Flask. And then once you install Flask, so just this is my repo, and then I have all the tags, so you can flip through, and then you can just basically check out one of these tags, and then basically the way Git works is it'll change as you go from one version to the next. It changes all the files around, and then you can see what changed. So we start out really basic. I do not recommend using VI. I don't know why I still use it. I cannot make myself switch to something newer. So this is our super basic app, and we'll build from there. Okay, so I don't want to talk too much about planning, but when you're making your app, it's good to spend some time at the beginning kind of thinking about what you want to do. So I try to think about, what's the best thing that I can do within the time frame, and I came up with a simple online journal. It's a little lame that there's no database, so basically whenever you restart the app, you lose everything, but like I said, I mean, in an hour and a half, it's just too much. So, but hopefully it will give you the idea how everything works. So these are all my pass and view functions, right? So I have the main page, my registration page where you sign up for an account, where you log in, log out, create a journal entry, and then basically anything else is gonna return a 404, basically not found. So I have to, as I go and write this out, I create all these functions, and then I use decorators to basically route those paths to those functions. Okay, and then so I called this and then basically in my application, I just created a skeleton. Can you guys see that? Is the font big enough? It's a little bit small. So I created a skeleton application, and I'm just saying for each of those views, I have a view function. I just name the functions what they do to keep it simple, and then there's a decorator on top that basically maps from the URL path into that view function. Okay, and then I wanted to show two things. Okay, so again, I have a infrastructure background, so I'm going to talk a little bit about the infrastructure part. Part of what I did here is, since we don't have a database, I have mock objects to kind of pretend what the database would do. So I have basically an object that hold my users and an object that hold my journal entries. Now for the user, I did not put in a password yet, right? We need a password. And this is kind of the first thing I want to get into. So I taught at college for a long time, for about 6 years. And one thing I definitely learned from teaching is that if I show you like a bad way to do something, no matter how much I tell you not to do that, you're still going to do it that way. So I'm not going to show you how to put like a text password in the file, because you should not do that. So therefore, I'm not going to show it. So instead, we're going to talk about a better way to do it. And a brief aside is, if I look at Flask, it's a micro framework. A micro framework, again, it's like a kit, right? Like a kit car. So it's a collection of components. So Flask is the main one, but there's actually 6 libraries that are all part of this collection. So Click is awesome. If you've never heard of that, I'm not going to talk about it tonight, but this is my favorite tool for writing command line apps. I love it. So that's very slick, and it's actually used by Flask. It's Dangerous is basically for signing stuff. We'll talk about that later on. Jinja 2 is a very popular template engine. So like if you use Ansible, for example, it leverages Jinja 2. A lot of tools leverage it, so that's a good one to learn. Markup Safe is basically, if you're writing a website, so think of like, for example, GitHub. In GitHub, I can basically do Markdown. So I can do fancy formatting like in my README files. So this is how you do it safely. And then finally, I don't speak German, but my wife does. So if I remember right, it's Werkzeug, which is basically tool in German. And this is a collection of tools. And within Werkzeug, there's a whole bunch of stuff we're going to talk about, including creating passwords. Okay, so. Even though it's 2018, and probably those of you that will work in the security space will cringe, there are still people that store passwords or secrets in plain text. And I think most people know that I can't store passwords. I think we've gotten there for the most part, but a lot of times, like how you go to the website and they'll ask you those security questions, which make me cringe because those are horrible, but that's another story. But those security questions, a lot of times when people ask you those are stored in plain text. So then somebody gets breached, and I mean, as mine as they would have just stored the password in plain text. So in terms of, you know, does this still happen? I mean, Marriott was very recent, but basically, security is hard, right? I mean, if you have, Google probably has some of the most talented people in the world, and they had to recently shut down their social media service.
Well, they're shutting it down in April.
Or they shut it down in
Google
April
Plus?
because of security
Months
problems.
earlier though.
Yeah, so basically, my point with this is, right, I still know a lot of people that think like, you know, I'm a really smart person and I'm just gonna do it on my own, and I hope I can convince you that that's a mistake. Don't try and do security on your own. You gotta use well-tested libraries. If you do it on your own, you're doomed. Okay, so I also, I don't want to spend too much time on this, but I want to go a little through the mechanics because this is important. Also for web security, I think it's important to understand this because I kind of hear this glossed over all the time, but I very rarely see people actually kind of connect the dots so you understand why you do something. So a hash function, all it is it's basically a mathematical function. You can take any amount of input and it creates some fixed output, and it's one way. So I can take anything and create a hash, but I can't take the hash and get back to the original thing. And the idea with a hash function is it's kind of like a checksum. Like a checksum on steroids. If I use this hash function, if I change even one character, one small character, the hash is completely different, totally different. So this basically makes it really easy to detect changes. Right, and I can't go back. So, everybody talks about password hashes, right? I think that's pretty common. So the question is a hash a good way to store a password?
No.
It's kind of a trick question, but there are some challenges. I mean, it's sort of right, but it's incomplete. Okay, and this is what I wanted to show. So Python, I love Python because it has everything built in, including a hashing library. So I can go into a Python shell, I just type Python, import hashlib. Basically, I have a whole boatload of algorithms. So here's the first thing, right off the bat, that gets people in trouble, right? So I have 32 algorithms. So how many people know which of these 32 algorithms are secure? And you know, it's not, you can look on the web, but you know, like there's a lot of stuff that's out of date, right? So some people will still tell you that SHA-1 is okay, which isn't true. It's not, right? MD5 is worthless. So it's not easy to keep up with this stuff, right? So let's say you happen to know that SHA-256 is a reasonable minimum. Okay, we'll start with that, right? So unfortunately though, there's some complexity, right? Does anybody know what's happening here? What does this not like? Pardon me? Well, the problem is this is a string, right? And a lot of languages are kind of grappling with this. And I actually did a talk a while ago about encoding, but this has to do with encoding. Strings are basically are decoded. And the problem with a string is strings have variable representations. So if I look at a string, if I say, like, for example, okay, that P, how many bits or bytes is that P? It depends. What's the encoding? You can't answer that question without more information. So if I look at a hash function has to deal with fixed binary data, which is not a string. So basically, in order to use the hash, I have to encode it. It's got to be in some kind of encoding, which the best one to use is this is pretty much settled. The best one, you should always use UTF-8. I mean, that's pretty much the standard. So that converts it into a consistent binary format. And this kind of gets into the, I don't want to get too much into the weeds, but with serialization, so basically whenever I have data, right, like if I'm using a programming language or I'm using a word processor or I'm using anything, if I want to take that data and share it with something else that's outside that process, like Like I want to print it, I want to send it over the network, I want to put it in a database, I have to serialize it. Because the way it's represented in memory in the computer and the way I have to send it outside of that memory are different. So this is the serialization process. So this comes up a lot. So, but I guess the way I try to remember it is, when I run a program, that program runs in a process. So as long as I'm staying within that process, I don't have to do anything special. But as soon as I leave that process, network, database, even another process on the same computer, then I have to worry about serialization and I have to deal with stuff like this. Right? So when you get into web frameworks, this is definitely something you have to understand because you're going to deal with this all the time. Now, if I look at that, right, this is still just an object that's not usable. So if I look and see at the methods, there's a digest, but that gives me back binary data. You know, I usually don't want to deal with binary data. So there's a hex digest, okay. But even getting this far, right, can you see how much I have to deal with here? This is even using a decent library, I still have to deal with a whole lot of details. This is probably too many details. Okay, so we got back here. Okay, so this is what I want to spend a little bit of time on, because a lot of people think that this is okay, and it isn't. This is not okay, even if you use a good hash. And the reason is because it's susceptible to brute force. Why do I care? Because Amazon or Google Compute, right? This is why, because basically we have virtually unlimited computing power nowadays. I mean, just whatever you want, you can get it. So the problem is anything that's susceptible to brute force is in trouble. And you could say, you know, yeah, but if it's totally random, but the problem is it's not. Because if we're going to be honest, most of this stuff is done by people, and people make horrible passwords. So it doesn't matter how good your hashing or encryption algorithm is, if what you encrypted is easy to guess, then somebody's going to brute force it and reverse it, right? So this is the problem with hashes. So this is why you can't use them. The other thing that you might not know about if you don't have a security background is something called rainbow tables. So these are basically like pre-computed attacks. And you can get these on the internet or buy them. And using these rainbow tables, you can go through massive amounts of dictionary attacks like really fast. So using rainbow tables, I mean, you know, you're toast, right? So this is why you absolutely cannot use a hash. Just remember, hashing is bad. Okay, so the solution though is really, really simple. It's been around forever, even back to the ancient Unix systems. It's called salt. And basically what this means is when you create the hash, you add a bit of random data. And if you add enough random data, then basically like let's say for example, I have 100 different options. So every time I hash something, there's 100 different possibilities. Well now if I'm going to brute force it, now I have to do it times 100. And if I make that like 10,000 or 100,000, then now I'm making the brute forcing impractical. So this is the problem with just a plain hash, is it not strong enough? You have to use a salt. And the other reason, this goes back to why it's important to use a good library. You know, how big should the salt be? How much entropy should be? What's the right algorithm? How many rounds? You know, what's a reasonable compromise, right? You know, these are all constantly changing. And keeping up to date is actually pretty hard, even if you're in security. This is why it's so important that you have to pick a good library. Because a good library basically, pardon me?
If you had used the salt and you had, let's say, 100, and then somebody presented their password again, would you have to try it 100 times or half of that 50 to get that average?
Yeah, that was going to be my question.
It's an excellent question. Well, I'll show you in a second how it works. It's basically stored with the password.
You store the salt with the password.
Yeah, I'll show you when you see it. I think it'll make sense. Okay.
That's in my mind before you say it.
Let me show you.
Okay.
Because I have a
I'm
picture.
sorry.
Let me show you the picture, and then if it doesn't work, I'll come back to it. Okay. So anyway, so basically, you know, doing this is hard. Don't do it yourself. And one other thing too, if you deal with web apps, there's an awesome resource called OWASP, which is the Open Web Application Security Project. They've been around for a long time, I think since the early 2000s. It's like basically like an open group, all kinds of standards. These guys wrote the book on security. I mean, anything you want to know, they pretty much have it, including best libraries to use. So, what I would say for Flask is, again, going back to that toolkit, Werkzeug, is they basically have some helper functions, and if we look in the helper functions, they have reasonable defaults. They basically pick a good algorithm, they pick a good salt, the salt is a reasonable size, and you also want to do basically iterations. So essentially, like when you're calculating the hash, you want to make it slow on purpose. Right, so for example, Werkzeug uses 50,000 rounds. And the reason you want to make it slow is because you want to make it infeasible to brute force it. So you basically add all these knobs in, and again, the nice thing about using a library is all these decisions are made, all the defaults are reasonable and safe, and then you don't have to worry about making a horrible mistake. So from Werkzeug security, I basically have check password hash and generate password hash. And then Dave, to go back to your question, when I create the password hash, basically this is what's stored. So this PBKDF2, that's the algorithm. SHA-256, that's the hash I'm using. 50,000, that's how many rounds. And then this value between the first $2 that's my salt. So basically, because this is stored, I know that the library is smart enough to say I have to use that salt to basically get the right hash when the user gives me a password. And if you look in your Unix password file, it's the same idea.
So
Unix
that
has
whole
been
string
doing
gets
this.
stored in the database.
Pardon me?
So that's whole string
Yeah.
stored in the database.
Yeah.
Portion of it is a hash.
Yeah, so only the everything after the second $sign is actually the hash password. Between the $2 is the salt, rounds, hash, and hashing algorithm, and then the password
But
algorithm.
isn't that storing the key then to your password in plain text in the database?
Well, no, because remember, with a hash, you can't go from the hash back to the password. So all this is telling you is, so when somebody gives me a password,
Okay, yeah.
I basically have to use this salt to check if I get to that hash.
To encrypt their password and check it against this?
Exactly.
Yeah, okay.
Now, if somebody dumped this, then yeah, it helps them brute force it. It makes it easy. But even if somebody has this, you can't use a rainbow table. The way rainbow tables work, this salting defeats
You've
them.
guaranteed that they've got 50,000 things that they have to do before they can get to it.
You make their life miserable. So
Yeah.
I mean, this is why the right kind of encryption is so important, because if you do it, I mean, even if somebody gets it, there's really nothing they can do with it.
Maybe the answer is in the first couple characters of what you're storing there, but you mentioned that the number of iterations and so forth might change because, and libraries would reflect those changes. If you're storing this, I would think that from the time you set the password to the time that you try it, it had better not change any part of the algorithm or the hash won't match.
Defaults could
What do you
change.
do about version
Yeah, that's a
control?
good question. I haven't, so in general, I'm surprised, because I've done a lot with security, I've never actually dealt with this specifically. In general, with databases, you basically have like a migration utility. Like for Flask, it has Alembic. I mean, I don't get to talk about it tonight. And then basically, your migration utility, as you change the schema, it basically keeps updating it, so your currency can go forward and back. And you basically have to do something like that. If you're going from like an old format to a new format, you'd have to do like a schema change. But I mean, in terms of, in terms of like changing the algorithm or major changes, that's usually slower. Like algorithms, change, maybe 10 or 20 years, so it's
Right,
just
so
not that common.
The algorithm there, SHA-256, is a well-known algorithm. It's not changing.
Yeah, that's
Yeah,
relatively new.
SHA-256 is going to produce the same thing, every single time.
Now, I mean,
But
50
what we
years.
were talking about rounds, for example, changed.
But that's specified right there. You got 50,000.
I never looked entirely into the rounds. I just know that you basically have to go through that many rounds to do it. It's trying to slow it down. I will say, Unfortunately, we're not safe for 50 years because of quantum computing.
Yeah.
That
Right,
probably will
but
make.
SHA-256 is gonna continue
I
producing
think,
that value.
I think 384 and 512 are resistant. I don't think 256 is strong enough, if I remember correctly.
SHA-256 is not gonna change 50 years from now.
But think of it this way though,
Hash
this,
something now with SHA-256.
Yeah, that's true, that's true.
In
The
50 years,
result-
it's still gonna hash the same.
But the question is, will it be safe?
No.
Well,
Yeah,
no.
probably
I
not.
wouldn't guarantee that.
Probably not.
But
for
think of it
50
this way though,
years.
the way that that's being laid out there, it's breadcrumbs. It's basically, these are the steps
Yeah,
that you need
yeah,
to do
yeah,
in order to
exactly.
replicate this. At a later point, you can say, change your password, and then you change your password to
When they
whatever
change
the new
password,
algorithm
you do it
is.
the new way.
Yeah.
It's, the defaults will change, but here you've encoded the
So-
values used.
If you're asking like, how do I migrate somebody from like an old password format to a new password format? I mean, I think,
Ask them to reset their password.
Yeah, exactly.
I've just never run across that, because I think basically, like, your systems tend to basically require replacements sooner than the algorithms.
Yeah.
We probably
It's-
run into that with like LinkedIn during their last breach, they forced everyone to change
Yeah.
their password.
Exactly.
That's probably what was happening.
Or you just reset everybody's
Well,
password and, yeah.
As you said, there's also utilities, like MySQL changed their default password scheme for things, and there was a
Yeah,
password
you
utility to
can
update.
do a migration, so, but, so it's possible, it's not, you know, it's not something that you run across commonly, unfortunately. Okay, and then I just wanted to kind of highlight this. So basically, if I have the same password, see how the hash is totally different depending on the salt. So that's why you need that salt to basically, when the user gives you the password, you have to know what salt was used to generate the hash. And then basically, you know, this will basically say, is it right or not? And then, like, you know, it's gotta be exact right. If I even change one little character, it's gonna say, you know, no, it's not the same. So basically, the bottom line with, I mean, I know it's a lot of details. I guess I'm hoping I'm convincing you that the details are sufficiently complex that it's worth using a library. But if you use a good library, the library abstracts away all the details and it's not that bad. Okay, so, you know, hopefully nobody would put a password or a secret in their code. Although actually the other day I screwed up and put a key in GitHub, but actually GitHub was, they have some new machine learning algorithm, so it sent me an email right away and warned me. So that's kind of nice. It was an API key committed to GitHub by accident. So, but generally you don't want to do that, right? So there's lots of options. Really the best way is to use a password vault, but that's another topic. But a reasonable way is you can just stick it in an environment variable. So you can create just like, you can create like a local environment variable, and then basically in that environment variable you can put like secrets and passwords, and then you basically put this in your git ignore. So if you don't use git ignore is how you say don't check this into my repository. So this is just something that's locally significant, and then when your program starts up, it's gonna load these environment variables, so that way it's never exposed. And so there's a library to use it, and just to show that real quick. So it's pretty straightforward. I'm using two of this .env and OS, which is from the standard library, and then I basically just use that. I load this. This is going to load everything from that file I just showed you, and then I can use os.envir.get to basically load the environment variable for any passwords or secret keys I need. Okay, so next big topic are templates. So again, probably the biggest reason for templates, you know, the most obvious one is, so we can see in these view functions, we're putting in some super basic HTML tags, right? So H1, here's my large header. But can you imagine if I was going to actually write complex HTML and CSS code and embed it within my Python script? I mean, you know, you don't want to do that. That'd be horrible, right? You basically want in your programming language, you just want stuff for your programming language. If you're gonna write HTML or CSS or JavaScript or something else, that should be in its own file. So basically you can use a tool just for it, right? Because if I embed HTML within my Python, then I can't use like an HTML, or it's hard to use an HTML linter, or basically use tools designed for that. So I want to separate that out. So what templates do is, templates let me put my HTML and CSS and JavaScript somewhere else, and then basically I can bring it in and render it as I need it. Right, or the separation of concerns. Okay, so when I create Flask, it expects in the top level directory, it expects a templates folder. And that templates folder are gonna have all my templates. So I basically, I'll show you this. I create a base template. So this, I will say, you know, this app is kind of like simplified to fit within the 90-minute window. So there's a lot of stuff. If you look at the HTML, it's not perfect. There's stuff that's missing, but hopefully it's enough to give you the idea. But the nice thing is I can have a base template and I could actually create a proper HTML page with all the proper elements. And then for all my other pages, rather than having to recreate all that boilerplate, I just say everything inherits from that base template. Okay. Okay, so now I added in this templates folder. And then this is pretty simple. This is my base template, so I basically have my head and my body. And then again, so for my template I use Jinja. Jinja is basically like a DSL. It's like a subset of Python. So most of what I can do in Python, I can do within Jinja. And Jinja works within the curly braces. Pretty much anything within the curly braces is Jinja. So if I have a curly brace pound, that's a comment, so I can throw comments in. And then the curly percent is almost like Python, except it's a little different, but you can get the idea. So I can do if, else, end if, I can do fors, I can do withs, I can do blocks. So what I'm doing here at the top is I'm saying, in my template I can pass in variables or information, almost like I'm calling a function, and I'm saying, if I get a title, I'll use it, otherwise I have a generic one. And then the next thing I want to explain is the double curly braces. So the double curly braces on line 15, those are basically for variables. So if I pass in a variable, it's going to substitute the variable in for where that double brackets or double curly braces title is. The other thing that's pretty useful is this URL for function. So when I create my app and I have all my view functions and my routes, usually I want to try not to duplicate stuff. So I'll basically say in all my routes I'll have all the URLs. So rather than repeating all of those URLs here, I can basically say put in the URL for this view function. Put in the URL for, so for main, login, and register, it'll basically rewrite that to whatever the URL is. That way, if I change the URL, I only have to change it in the one place, and I don't have to go search and replace in my code. So this is a general design pattern that's recommended for Flask. And then finally, this part at the bottom, this block is basically we're gonna, for the other templates that will inherit from this, they're gonna plug in the content there. So basically all the boilerplate, you know, basically I have my header, kind of like almost like a nav bar, except it's more basic, and then everything else will inherit and plug in there. And the other templates are pretty simple. So that extends basically means it inherits from base. And I think, yeah, this is the only one that really has anything at this point. And then the only thing I add here is I add a for. And this is basically just going through that mock journals object and will basically show all the journal entries. Okay, so what I added here is I added this render template function. And then now, instead of returning text, if I look at my view functions, I basically return this function, render template, and then I'm gonna call the name of the template. And then render template knows to look in that templates folder, it's gonna find that file, and then everything I pass after that, or it's kind of like a function, I'm passing those variables. So when I pass those variables to the render template, that's available within that template to use as variables or data. Okay, so now we have, basic application flushed out, we have basic templating. So the next thing is forms or user input. So in terms of signing up, logging in, basically passing me data, forms deal with all that. Now, forms are not horrible, but the thing that's tricky with forms, there's a lot of basic validation stuff that's just enough of a pain that it's nice to use a library that deals with it so you don't have to deal with it in JavaScript, just let the library deal with it. The other thing that's a little harder though is dealing with some of the security issues is pretty tricky, so the library can help us out with that. And there's two more we're going to talk about. So Flask WTF, which is kind of a memorable name, that deals with forms, and then Flask Login will deal with session management. And I just want to point out, if you actually go and look at the Flask homepage under extensions, there's probably got to be over 50 of them. So it's nice because just about anything you can think of, somebody's already thought of it and has a library for it, so you don't have to do it yourself. Okay, so when we use this library, there's a couple basic things. So for example, if I have a registration form, I'll ask maybe somebody for their username, their email, and their password. So basic validation is, did they actually put something in? Is the email address look reasonably like an email address? Do the passwords match? So basic stuff like that. So it's not hard to do that, to write some JavaScript code, but if the library just, makes it completely easy, why not? So that's the idea, is dealing with all the basic stuff. The more dangerous one is the security, right? I want to make it hard to forge the input. Okay, so CSRF, or cross-site request forgery, this is a really common attack. And the easy way to remember what CSRF is basically, if somebody does a CSRF, you might go to some page and click on a link, and the attacker is going to transfer all the money out of your bank account into their bank account. So that's kind of an undesirable thing. That's a CSRF attack. So the way to protect against those is you basically use a hidden token. And this hidden token appears on the page as a hidden input form, and when the user basically submits the request, they have to have a matching token. And the attacker doesn't know this because they're blindly forging it. So this is actually pretty hard to do it right. And again, referring back to OWASP, OWASP has an awesome write-up on this. They even have like a whole test VM that you can hack, and they'll show you this is bad, this is good, everything. But this is actually pretty hard to do right. So this is the main advantage of using the library. The library is battle tested. Somebody's already solved this for you. Okay, so one more thing I want to talk about from a security point of view is when you use this CSRF feature, this anti-CSRF, you have to have a secret within Flask. And the secret basically lets you do things like session management and these tokens. And what I wanted to point out here is I can think of a recent story. So I was recently setting up a VPN, something I've done a million times. And when I talked about setting up the VPN, somebody's like, oh, I'm gonna, generate 10 random characters, and I'm like, how about 40? And they're like, oh, 40 characters, that's too hard, I can't remember it. And I'm like, exactly, that's the point. And there's actually some good papers on this, but the easiest way to remember this is, if a human generates a password, it's weak. If you can remember it, it's weak. So the key is when you're doing any kind of a secret, you have to use a tool. You've got to use a tool or it's worthless. If you don't use a tool, it goes back to the brute forcing we discussed earlier. There's all kinds of tools available to make it easy to brute force, and then it's worthless. So what I wanted to show real quick is, again, if I'm using Python, I have two different things. I have my hash lib and my HMAC. HMAC is basically a keyed hash, or basically I'm taking a hash and applying a password to it. So if I use the HMAC function, what I can do is, in addition to encoding it with SHA-256, I also apply some kind of a password. And by using the password, so this is a horrible example, but if I use a good randomly generated password, then it's impossible to forge. And so I thought this is probably a little easier to understand if we look at a cookie. So when I look at a cookie, so again, I can use Werkzeug to generate a cookie. So from Werkzeug, I import this secure cookie library, and all a cookie is a bunch of basic data. Like I might store like a user ID, maybe some data for a shopping cart, right? Just some basic stuff. Now, a cookie, you can see them, but a cookie, it's usually just base64 encoded. It's typically not encrypted, which means that there's actually sites you can go to and you can see what's in the cookie. So you don't want to put anything secure in there, you just typically put identifiers. Now, when you put all those identifiers in there, the reason you want to use an HMAC or this password is, when you do that, you can basically put a timestamp on, say it's only good for this amount of time, and then when somebody sends the cookie back, only you know the password, and you can say, okay, is this valid or not? Because if somebody generated it besides me, they're not going to know the password, and it's going to come back as invalid. So again, so here's what my cookie looks like, and basically, if I have the right password, I get all the data back. Now, if I even apply just like a space, something trivial, and then basically try and decode it, it will say, no, invalid, give me nothing back. So the point of this is, if I just have a cookie by itself, it's the same as with the password. If I have a cookie and I hash it, the hash is good, but the problem is anybody can intercept that cookie, they can put their own data in, they calculate the hash on their own, and then when they send the cookie back, well, the hash is valid, right? So that's the problem with hashes. A hash will tell you, yes, this data is represented by the hash, but you don't know if somebody forged it. The only way you know if you created it is if there's a password. So you can only create this hash if you know the password. So this password is critical, because otherwise you don't know if you're in control of the cookie or not. Okay. So one thing okay, so when I put these forms in, so I'm loading these WT forms at the top, and basically, what's out of time here? Now again, I'm trying to keep this simple, so I kind of stuffed everything in one file. I would say normally put these in their own file, but with these forms, I just create a class for each one. So I have my login form, registration form, and entry form. And then it's pretty straightforward. I have the field names, and then I say string field, password field, submit field, and then basically what it's called, and the validators is, do I have to have data? And the data required, so if somebody tries to submit the form and it's empty, it'll basically pop up a box that says, hey, you have to have something in here. So these are pretty straightforward, and then it deals with all the validation and sanity checks. Do the password matches? I mean, I took the email address out of here, but it's the same thing. Is the email reasonable? And this does all my sanity checking for me, and it also deals with the security checks, like the CSRF.
Real quick question for you.
Sure.
On the form code there was, go back to that, if you want to remember, the validate username function, does that get called automatically when you instantiate the registration form class?
Good question.
Do you increase the font size?
Yeah. Yeah, so, with the forms, so this username field up here on line 37, if I create a function, validate, and then this username here matches that username from 37, and this is basically saying, I want to apply my own checks. So in this case, what I'm doing is I'm saying, so username.data, that's what actually came back from the form, that's the user input. I'm saying, if that username already exists, it's in my user's object, then I raise an error. And basically, the library catches that error, and we'll go back to the user and say, please choose a different username.
Yeah.
So this is my check to make sure you can't enter a duplicate username. And then I have something similar here, you can't enter a duplicate title.
Yeah, so I understand the function of it, I just, I don't see a call directly to validate underscore username, so I'm wondering.
It's just, the library just,
The class knows.
yeah, the
to
library just-
execute any function that's inside of that class, basically?
yeah, so anything that starts with validate underscore and a name that matches one of the field names will be used as a validation function. That's done by the library.
Got it.
Kind of like with your unit testing,
Mhm.
you have the special function names.
Yeah, yeah, auto load.
Yeah.
So,
And then basically this form hidden tag on, I think it's line 5, that's my CSRF protection. So basically that puts in that hidden token that protects me against the CSRF attacks. And then I have, for each label, I basically have the name, and then the label says, create like an object on the page. And then the size is basically saying, that's how big the box is. And then this error loop is saying there can be one or more errors. So if there's any validation errors, this for loop will go through and it will print all the validation errors under the box. So like if I had an email check, I can say this is invalid or whatever. I can list one or more. And that's it. And then this is kind of basic, but then you're changing the color to red using CSS. But and then form.submit at the bottom. So none of this stuff is too hard, but it just saves you from doing all the boilerplate in JavaScript. Oh yeah, and one other thing I wanted to show is flashing. Okay, so walking through, here's our registration function. So we instantiate a form that's matching the class name. So this form validated on submit. So that's basically saying all the checks that we define in that class will be enforced. And basically, if all those checks, like if there's a missing field, passwords don't match, something like that, then basically we fall through that block and we basically re-render the page. So we basically prompt the user again, and then any errors are passed to and we display those errors. If the form is valid, then we keep going. We're gonna take the entered password name and generate a hash, and then this flash message. Flash is kind of like a print to a user. So we pass this to the web page, and then we can just keep stacking them up, and then in the web page it will print all these messages. And then finally, this one is important too. This redirect. So there's it's called the post redirect get pattern. And so basically it's critical that whenever you do form data, you always want to do a redirect at the end. Because if you don't do the redirect, has anybody ever seen where you go to a site and you hit refresh and it says confirm form data resubmission? Mm-hmm. That's basically because somebody forgot to do this. So, and that's a completely confusing message, even for a technical person, so you never want to do that. So basically, whenever you have a post, you always redirect to another location, so that way if somebody does a refresh, it'll refresh that get and not the post. You never want to end, so anytime somebody does a valid post, you always want to redirect to a get, so the user will never get that error. Yeah, and then basically for the Flash message, I added in the base template. So this with block is the same as in Python. This is how I get all my Flash messages, and then basically I just go through and list them out. So if there aren't any there, it will skip it, and if no matter how many there are there, it will just go through and kind of print them out on the web page. Okay, and then the last topic is logins. So for session management, we're going to leverage cookies. And with cookies, we're essentially sticking the user ID in a cookie, and then as long as they have a cookie with a valid user ID, we know they're authenticated. And then we can give them access to certain portions of the site. So this is how we get login and log out and restrict views. So okay, so Flask login, we current user is basically if somebody's logged in or not, and then we have some basic functions. Going down, so with Flask login, I set this up. I say login manager equals this class, which I get from that application. And then basically what I have to do is I have to create a specific function that handles logins. And essentially what this guy's gonna do is, the Flask login extension is gonna pass an ID. And what this has to do is this has to basically see, is that a valid ID? Now I put in my code, this is awful. I'm a little embarrassed, because basically what you should be doing is you should be using a database. But again, I mean, in terms of, we're just don't have enough time to do it. So all I do is I have my simple dictionary and I just go through and see if I can find a matching ID. And then once I have this, so the big one was, like, for example, if I want a user to be able to create an entry, I'm gonna say login required. So basically, if a user tries to go to this page and they're not authenticated, it'll redirect them automatically to the login page. So this is kind of slick because it makes it real easy to restrict pages. So one thing that would, okay, actually one last thing and I'll show the app. What's amazing is that it seems like non-technical people have an amazing knack at finding any bugs that we missed. They just have an amazing talent at it. So you need to deal with 404s, right? Anything where they go to some place you don't expect. And you also need to deal with application crashes, which sometimes are gonna happen. And then finally, there's one more thing I want to show with debug mode. Okay, so this Flask, I didn't mention this too much. So in modern versions of Flask, I basically do everything from the command line using this Flask command. Question?
I got a question on your login and login required, the way your code was.
Mm-hmm.
Could somebody create their own cookie on their machine with somebody's username and then maybe validated with actually not knowing the password and being logged in?
They could if you didn't use a good secret. So remember we talked about the HMACs and you have to use a good secret?
The cookie's encrypted.
So, well, the cookie's actually not encrypted, but the hash is encrypted. So the signature's encrypted.
It's like it's signed.
Yeah, it's signed, exactly. So basically, they can forge it, but then when you go to check the signature's not gonna match because they don't know what your password is and it's gonna reject it.
Okay.
So that's how you protect against that. That's why I was trying to go through the importance of using the secret in the HMAC. to protect against that. Okay, so everything in Flask is run from this Flask command, and you can actually have a file called Flask env, and this file, you put the name of your app, and then you can also put if you want to run in development mode. Okay, so notice when I start this, it's saying debug mode on. So this debug mode, it's really nice if you're writing the app, because every time you change any one of the files, it just automatically restarts the server. So you don't have to like stop it and restart it, which is kind of a pain. So that's a great feature, but if you, and on the Full Stack Python site, there's an article on this, if you leave this on, it's guaranteed that you'll get owned if you leave this on in production. So you have to remember to turn it off for production.
I think it gives you an ugly warning message too.
Yeah. But it is really handy because, so let's say I go somewhere and basically my application crashes. So this is the other reason you don't want to leave it in debug mode. So then I'm going to get this, scary looking trace back. But the nice thing is, if I'm actually a developer and I want to see like what is going on here, I can click on this little console, and then I can basically dump out my current stack frame, and it'll show me everything. I just put that in there on purpose to show you, but it's kind of cool because for basic debugging, you can actually go anywhere. You can go through the whole stack trace, and you can see like what were all the variables, what was everything set to. So it can kind of be cool. This is cool for you. You don't want somebody else to be able to do this. So once you're ready for production, you want to make sure you turn this off. Right, and then you basically replace it with some kind of a standard error page, right? Because you don't want the user getting a stack trace. And then if if they go somewhere else, so you basically just so these are your most common errors. You want to make sure you handle those errors. And you'll see this at any site, right? So that you get some kind of a form. And then I didn't go through logging tonight, but you can set up logging, so it'll basically capture all these events and automatically email you. So if I go now, so this is super basic, but hopefully it at least illustrates the point, right? So I go to my registration form. If I try to submit, it's going to tell me I have to fill out the forms. So this guy at the top, this is my flash message that I sent the user. Ooh, I must still had a cookie. And then I can log in. And then once I'm logged in, I can create a journal entry. Right, and then it's going to add it to the page. And then if I log out, you can see the bar at the top changes. That'll be dynamic depending on whether somebody's logged in or out. So this is super, super basic, but hopefully at least kind of gives you a taste of like the various stuff and things you can do. So any questions on that? It was a little fast.
Any questions in general?
Yeah, or any questions? Okay, so this was, I made this application really simple. I mean, you wouldn't structure it like this. You want to separate stuff out and ideally probably package it into an application. But again, hopefully it illustrates a lot of the concepts. I'll give Craig all the links. So if you're curious, you're welcome to go and clone the repo. I'll put the slides and everything up there. If you have any questions, feel free to reach out. In terms of what's next, so I mentioned this, we didn't talk about databases and ORMs. So this is huge because right now, every time I stop the app,
May I have your attention, please? The time is now 8:30 and the library will be closing in 30 minutes at 9 o'clock. Please be advised that the library's internet connections will shut down approximately 10 minutes before closing. Thank you.
so this is the next big step, is you want to use an ORM or an ODM in some kind of database so you can actually persist everything. The other thing is the application is very ugly, right? There's no aesthetic appeal whatsoever. So basically all your aesthetics come from HTML and CSS styling. If you haven't looked at CSS recently, you can do some amazing stuff. I mean, you can do advanced 3D graphics and all, I mean, just unreal what you can do with modern HTML5 and CSS version 3. So that's sorely missing. Yeah, exactly. Typically you use something like Bootstrap. It's probably the most popular one, really easy to use. No utilities, so you want to capture all your logs, you want email for things like password resets, and then maybe, periodically sending out logs, so we didn't cover that, those are pretty straightforward. If you want to make it like a modern application where it has a rich interface, then you probably want to use a framework, something like React or Angular or Vue for an advanced single page application. We didn't talk about deployment, so there's lots of deployment options. You can use an IaaS provider, where you use a VM or a VPS. You can use PaaS, something like Heroku. You can package it up in a container and use anybody who supports containers or Kubernetes, so there's lots of deployment options. Also, as your apps get bigger, not only are you going to want to put them into separate files or modules, but you're also going to want to group things. So here are all my authentication views, here are all my main logic views, maybe kind of split them into groups, and for that use blueprints. The other thing that you might not like, nobody called me out on this, but we had a lot of global state, right, which is really bad, especially if you want to do concurrent access. So blueprints allow you to get rid of all the global state. You basically create a factory function, and then you import all your blueprints into that, and then you can have multiple app instances. So that's another thing we didn't talk about, but that lets you scale. And then obviously unit testing to make sure everything's working and you don't introduce regressions. And then, then beyond that, you can get into stuff like WebSockets and WebRTC for some of the newer modern things. So there's a lot of other areas, and I guess I hope, I really like the Trello board, so I guess I hope with kind of covering the different areas in these, if there's things that you're interested in, any of these or any of the things we covered, yeah, put them on there or put them on Trello, right? Because that way everybody knows what people are interested in, what areas are interesting to explore. And then one last thing I wanted to show, so I do this a lot at work, so I've been trying to work on roadmaps for people that say, well, that looks cool, but I don't know where to get started. So Linux is crucial. I mean, pretty much anything in the modern time. I mean, Windows is popular, but I mean, even in Azure, Linux is taking over. So these are great Linux classes. Bunch is the most popular distro, and they're all pretty similar. So there's a whole bunch of online providers I have in the notes where you can take classes if you want to get up and running with Linux. For programming, I put some stuff I liked. This Python for Everybody series, if you don't know Python and you want to learn, this is one of the most popular online courses in the world. It has fantastic reviews. I've talked to a lot of people personally who have taken this. It was created by a professor at U of M, Ann Arbor. Excellent course. There's a whole book and everything. So that's a great way to get started. If there's another option too. And then I also, for web development, everything I mentioned at the beginning. And then I also threw in some podcasts I like. So hopefully,
we'll get those up on the site.
yeah. So any other questions? I guess I'm kind of putting you on the spot, but I mean, what do you think? Is it better if we try and actually go through some code, or do you think it's better if we do everything on the slides? Anybody have feedback on that?
The way you presented, I really liked.
Yeah.
You liked it? Okay.
Yeah. And I think looking at actual code really helps out, especially something that's working. Examples, because otherwise, yeah, if you do it on the slide, then it's it's kind of divorced from the whole, this is what's actually working versus,
And then being able to go through it from the GitHub and just go through the different versions is pretty nice too.
Yeah, that was really cool. I hadn't seen many people do that before, where you're checking out different versions to go, to progress through.
I like that. I have to give credit to Miguel Grinberg though. I got that from him, because I took his class and he did that for everything. I thought that was really slick. So I basically copied what he did.
And the cool thing is, if you wanna follow along with the progression of the application, you can see the different versions and
Yeah.
the diffs between all the files.
We just check the branches.
So you can do that, but what Miguel did and I like is basically as you create a branch, you can tag it. So you do a git tag minus A and then the tag number and then a comment. And then basically you can, in newer versions of Git, you can just check out the tag. So then basically you tag every key point and then you
Yeah.
just switch those.
I did that with Bazaar for a presentation over at PenguinCon and that. So it's really helpful for doing a presentation like that, where you just, every time that you do something, you just keep checking it in, checking it in, checking it in. Then you can
Yeah.
use, there's a lot of tools for like pulling back, like I was using LogWatch, I think, or
Okay.
Logger, I think it was, I don't remember what it's called. It's been a while. Anyways,
Just one caveat though, if you use tags, they're great, but by default, they're not pushed to remote repos.
oh god, yeah.
Yeah, I think you have to do a git push
Dash,
branch
dash,
name dash
tags.
dash tags, and then it sends them. So you've got to remember to do that.
Thank you very much. Can I ask everyone to please fill out these cards and get them